Throughout most of human prehistory, Homo sapiens was not alone. For hundreds of thousands of years, our species coexisted with multiple other human relatives, each uniquely adapted, each vying for a place in the unforgiving ecosystem of the Pleistocene. From Neanderthals in Europe to Denisovans in Asia to Homo erectus across Africa and Southeast Asia, the Earth once hosted a diverse family of intelligent hominins, but today, only one remains. Why? The answer lies in a fundamental law of evolutionary biology. In times of change, survival favors not the strongest, but the most adaptable. Natural selection relentlessly filters out those who fail to keep up. In a world shaped by climate shifts, resource scarcity, and interspecies contact, adaptability became the ultimate currency, and Homo sapiens proved to be the most agile trader. What set us apart? Not brute strength, not resilience alone, but cognition. Modern humans displayed an unprecedented leap in cognitive capabilities. While other species had large brains, Homo sapiens used theirs differently. We created complex tools, organized communal hunts, and communicated with a level of nuance unseen in any other hominin. Language, structured, symbolic, and recursive, became our most powerful tool. It allowed us to share ideas, transfer knowledge across generations, and plan for an uncertain future. This wasn't just intelligence, it was meta-intelligence, the ability to learn faster than others, to adapt strategies by observing and imitating, and to transmit innovation at the speed of speech. Where other hominins relied on instinct and trial and error, Homo sapiens developed memory-based decision-making. We learned to remember past patterns, anticipate outcomes, and adjust behavior accordingly. This allowed groups of sapiens to avoid dangers that others walked into repeatedly. It also meant knowledge no longer died with the individual. It was passed on, refined, and expanded across generations. This transfer of knowledge was not limited to survival skills. It extended to social norms, cooperation, division of labor, and abstract concepts like ritual and belief. These were not luxuries. They were evolutionary advantages. A clan that knew how to coordinate, that remembered a successful migration route, that respected the wisdom of elders, was a clan more likely to survive. As Homo sapiens spread across continents, this flexibility became critical. We adapted not only to geography, but to the presence of other human species. In many cases, we didn't invent from scratch. We observed, absorbed, and improved. In Europe, we encountered Neanderthals who had long mastered cold climate survival. Evidence suggests we borrowed some of their technologies and possibly even cultural practices. But crucially, we did it faster. And in evolution, faster often means further. This edge in adaptability created a cascading effect. Larger, more organized groups, more efficient foraging and hunting, better protection for infants and elders, and greater resilience in the face of disasters, whether a drought, a volcanic eruption, or a rival group encroaching on territory. Over time, this led to what evolutionary biologists call a selective sweep. It wasn't necessarily violent. It was the gradual outperformance of one species over others. Where Neanderthals hunted in small bands, sapiens formed expansive networks. Where others repeated behavior, sapiens innovated. Where some preserved knowledge in objects, we stored it in language and stories. We did not win because we were superior in every way. We won because we adapted faster than others could recover. Intelligence, in our case, was not just the ability to think. It was the capacity to remember, to teach, and to imagine, to build a shared understanding of the world and act on it together. That, in the end, was the decisive factor. While many species could survive, only one evolved the cognitive tools to reshape the environment, to form symbolic cultures, and to outlive the competition, not through brute force, but through collective learning. We were not the strongest, we were not the first, but we were the most adaptable. And that made all the difference. Part 2. Invisible weapons, culture, tools, and allies. Survival is rarely decided by strength alone. In the long evolutionary struggle between species of ancient humans, Homo sapiens gained an advantage not through force, but through innovation, an edge sharpened by tools, culture, and unexpected partnerships. By 50,000 years ago, Homo sapiens had begun developing a technological toolkit more advanced than any of their predecessors. Stone blades were no longer crude, they were finely crafted, specialized, and efficient. We see the emergence of composite tools, wooden shafts combined with flint or bone tips, hafted together with resin and sinew. These weapons extended human reach and precision, especially the spear thrower or atlatl, a device capable of hurling projectiles over 100 meters with deadly accuracy. This innovation changed the rules of hunting. Where Neanderthals may have relied on close-range ambushes, Homo sapiens could strike from a distance, reducing risk and increasing their range of prey. They also constructed snares, traps, and fishhooks, expanding the range of animals they could exploit. In essence, they widened the ecological niche of early humans, allowing for more reliable food acquisition across diverse environments. But tools tell only part of the story. Homo sapiens also produced symbolic objects, evidence of abstract thought. From the earliest cave paintings in Europe and Indonesia to carved figurines and personal ornaments, we see a mind concerned not just with survival, but with meaning. These expressions, lines etched into ivory, ochre handprints on cave walls, beads strung into necklaces, signaled identity, memory, status, and possibly belief. Culture became a second form of inheritance. It wasn't just genes that shaped survival, it was the transmission of knowledge, ritual, and artistic expression. Symbolic communication deepened group cohesion and created shared stories, an invisible glue that held communities together, even in times of stress and migration. One of the most significant and often overlooked developments during this time was the domestication of the dog. Genetic and archaeological evidence suggests that wolves were first domesticated by Homo sapiens as early as 30,000 to 40,000 years ago. These early dogs were not pets in the modern sense, but working allies. They tracked prey, warned of predators, guarded camps, and even helped humans stay warm at night. The human-dog partnership may have dramatically enhanced hunting success and survival in harsh Ice Age conditions. Neanderthals, as far as we can tell, never developed this alliance. It was a breakthrough not only in biology, but in cooperation across species, a unique step in human evolution. There's another subtle adaptation that provided a significant social advantage: the white of the human eye, or sclera. While most primates have dark sclerae, Homo sapiens evolved a striking contrast between the iris and the surrounding eye tissue. This makes gaze direction easy to detect even from a distance. Knowing where someone is looking, or where a group is collectively directing attention, improves communication, coordination, and trust. It is one of the cornerstones of social interaction, and arguably one of our most powerful evolutionary tools. Together, these traits, tools, culture, symbols, allies, and communication, formed a tightly interwoven web of survival strategies. When compared to other human species, the difference becomes stark. Neanderthals, for instance, also made tools, crafted ornaments, and engaged in symbolic burial, but their toolkits changed slowly over time, often remaining static for tens of thousands of years. Their cultural expressions, while real, were fewer in number and variety. Denisovans, another close relative, remain archaeologically elusive. We know of their genes, but we know almost nothing about their way of life, art, or tools. The archaeological record suggests that Homo sapiens had a broader range of behaviors, and more importantly, a faster rate of innovation. New techniques spread quickly across vast distances. Cultural evolution, unlike genetic evolution, can leap across generations and continents within a lifetime. This allowed Homo sapiens to respond more nimbly to challenges, to copy successful practices, and to build upon them. This rapid cultural feedback loop, tool-making, symbolic communication, social cooperation, created a multiplier effect. With each generation, Homo sapiens grew not only in number, but in complexity. Their tools were sharper, their hunts more organized, their art more intricate, and their bonds more resilient. Invisible weapons, yes, but decisive. While other species of humans relied on strength, instinct, and tradition, Homo sapiens wielded imagination, memory, and meaning. That is what changed the course of history. Part 3. The competitors. Who disappeared and why? For most of human prehistory, Homo sapiens shared the planet with other intelligent human species. These were not primitive brutes. They were adaptive, social, and capable in their own right. But one by one, they vanished. The Neanderthals were perhaps our closest and most formidable relatives. For over 300,000 years, they thrived in the cold, unpredictable environments of Ice Age Europe and Western Asia. They mastered fire, crafted stone tools, wore clothing from animal hides, and hunted large game. Archaeological evidence shows that they engaged in symbolic behavior, burying their dead, decorating their bodies with pigments, and possibly producing music. Their brains were as large as, or even larger than, those of Homo sapiens. By all visible metrics, they were intelligent survivors, yet they disappeared. The Denisovans are more enigmatic. Known almost entirely from genetic evidence and a few bone fragments discovered in a Siberian cave, they lived across much of Asia tens of thousands of years ago. While we have little direct insight into their culture or tools, their DNA survives in modern populations from Southeast Asia to Melanesia and Australia. This suggests not only contact with Homo sapiens, but interbreeding on a substantial scale. Then there are the lesser-known hominin species. Homo erectus was the great traveler, a species that emerged in Africa nearly 2 million years ago and spread across Asia. They were the first to master fire, the first to leave the continent of their origin, and possibly the longest living human species in history. Yet by the time Homo sapiens reached their territories, Homo erectus was already fading. Homo floresiensis, often called the Hobbit, lived on the Indonesian island of Flores. Standing only 1 meter tall, they used tools and hunted small game. Their isolation on the island preserved them for thousands of years, but they too eventually disappeared, perhaps shortly after contact with Homo sapiens. Homo naledi, found in South Africa, shows a perplexing mix of primitive and advanced traits. Despite having a small brain, they appear to have deliberately placed their dead in remote cave chambers, a behavior once thought unique to more modern humans. But like the others, they left no descendants. Homo heidelbergensis is thought to be the common ancestor of both Neanderthals and Homo sapiens. They were large, robust, and capable toolmakers. Some groups evolved into Neanderthals in Europe. Others remained in Africa and gave rise to modern humans. But as a distinct species, they too vanished. Why did all these species die out? The reasons are not singular. Extinction is rarely caused by one factor. It's a chain reaction of pressure, stress, and failure to adapt fast enough. The most direct pressure came from competition with Homo sapiens. As our species expanded out of Africa around 60,000 years ago, we entered territories already occupied by other hominins. We competed for the same resources: animals to hunt, plants to gather, water sources, and shelter. Homo sapiens often arrived in larger groups, with more efficient tools and stronger social cohesion. Even without direct conflict, this alone would have put pressure on smaller, scattered populations of native species. Climate change played a second critical role. The Pleistocene was marked by extreme environmental volatility, glacial advances, sudden cold snaps, and long dry spells. Homo sapiens had the cognitive and cultural flexibility to shift strategies quickly, migrate when needed, and modify their tools and diets. Other species, especially those adapted to narrow environmental niches, struggled when their ecosystems changed. Isolation and low population numbers further reduced resilience. Many of these hominins lived in small, fragmented groups. This led to inbreeding, loss of genetic diversity, and greater vulnerability to disease. Once their numbers fell below a certain threshold, recovery became biologically improbable. Some species did not completely disappear, they were absorbed. Genetic evidence shows that Homo sapiens interbred with Neanderthals and Denisovans. Their DNA remains in modern humans, particularly among populations outside Africa. But these genes are fragments, not full legacies. The species themselves, as distinct groups with independent cultures and identities, are gone. Disease may have accelerated the process. As Homo sapiens migrated, they likely carried pathogens, viruses, and bacteria that local populations had never encountered. Just as in more recent historical events, such as the European colonization of the Americas, contact with a new population could have led to devastating outbreaks among unprotected groups. Finally, natural disasters may have delivered the final blows. Volcanic eruptions, droughts, and ecological collapses occurred frequently during the Pleistocene. In small, isolated populations, a single catastrophic event could eliminate an entire group. Taken together, these factors created a system of slow attrition. No one battle, no single plague or winter explains it all. But over thousands of years, species after species succumbed to climate, to competition, to misfortune. Homo sapiens remained, not because we were destined to, but because we proved, again and again, the ability to adapt, to connect, and to outlast. The others faded into memory, bone and gene, and we became the last humans standing. Part 4. Genocide or genetic absorption. When Homo sapiens spread across the globe, they encountered other human species, Neanderthals, Denisovans, Homo erectus. These meetings left behind more than bones and tools. They left a complicated story of both conflict and connection. Fossil evidence shows trauma, fractures, weapon wounds, even cannibalism. But genetics tells another story: interbreeding. Today, 1 to 4% of non-African human DNA comes from Neanderthals. Many Southeast Asian and Pacific peoples carry Denisovan genes. This reveals a paradox. Homo sapiens didn't just replace other species, they absorbed them. In some areas, interbreeding was common. In others, sapiens outcompeted or even wiped out native populations. Neanderthals likely succumbed to a mix of environmental stress, demographic decline, and limited gene flow. Denisovans contributed more to our DNA, but vanished from archaeology. A silent killer was disease. As sapiens moved, they carried pathogens that devastated isolated human groups with no immunity, much like what happened millennia later in the Americas. Some inherited Neanderthal genes still aid our immune system, though others are linked to modern illnesses. The extinction of ancient humans wasn't purely violent or peaceful. It was a mosaic of competition, blending, and chance. Over generations, Homo sapiens dominated through larger populations, more flexible diets, and faster cultural exchange. Other human species dwindled, not overnight, but inevitably. Their legacy survives in our blood, our genes, and perhaps even our minds. They are gone, but not entirely. Part 5. Why we survived. Lessons from the past. Homo sapiens wasn't the strongest or most numerous at first, but we were the most adaptable, and that made all the difference. We changed quickly. In freezing Europe, we hunted mammoths and wore layered hides. In the tropics, we fished, foraged, and built traps. Our diet wasn't fixed, it shifted with the environment. This flexibility extended to our shelters, social systems, and tools. Other humans mastered specific ecosystems. We mastered adaptation itself. We communicated in depth, shared knowledge, planned and remembered. Language allowed us to pass down lessons. warn of dangers, and prepare for the unknown. Social networks expanded, spreading ideas across lands and generations. In crisis, whether drought, disease, or disaster, we adapted, we endured. Our story isn't one of brute conquest, but of learning, organizing, and imagining. Our endurance carries a lesson. We survived not because we were better, but because we changed faster. And in our DNA, we carry the strength of Neanderthals, the resilience of Denisovans, and perhaps fragments from species long forgotten. Their instincts echo in us. Survival is not the same as superiority. The past teaches humility. It reminds us we are part of nature's long experiment, not its final product. Future generations will inherit the earth from us. Whether they endure will depend, as it always has, on learning, cooperation, and wisdom.